Hello everybody, this video is on solving equations with proportions 2. So by now you know how to solve them doing very simple fractions by looking at my first video on solving equations with proportions 1. Now I'm going to give you more complicated examples and different methods that you can choose to solve them. In this case here, you'll notice that I have two x's on either side of my equal sign. And it just so happens that they're both attached to fractions. So I would just like to reiterate that when I'm talking about proportions, I'm talking about fractions. And as much as you may be tempted to change these into a decimal, sometimes decimals do us more harm than good when they are complicated and long. So the purpose of doing this is so that you can understand how to use fractions in equations and not be afraid of them. They can actually be very helpful for you. When you're doing regular equations, though, when you have x on either side of the equal sign, what you normally tend to do is you just tend to bring your x's onto one side and your coefficients without x's on the other side. So that's what I'm just going to do in this example. When I do that, I'm going to subtract, not 8, but 3 over 8x on both sides. And I'm also going to subtract 2 on both sides in order to get my numbers on one side. And if I do that, I'm just going to leave this like this right now because I cannot subtract 3 over 4 with 3 over 8 right away, and you should know that's because there's no common denominator, and this is what I am left with. So at this point now, you'll notice that I do not have a common denominator, as I said, and I do not want to change these into decimals. The point of this is to keep them in fractions because you'll see that it'll be very, very helpful if you do. There are two methods that we are going to go over in this lesson. The first method is doing it with a common denominator, and the second method is by solving this equation by cross multiplication. You will also be seeing a special case of an equation with proportions when x is in the denominator at the end of this lesson. If we talk about the first method, this is where we were at the end of the last slide, where I'd put my x's on one side and my numbers on the other. The first way is to multiply everything by the greatest common denominator, and by everything I mean every single term. So here we have the denominator is 4, and let me just change this because this is incorrect. It should be 3 over 8. My apologies on that one, 3 over 8. Okay, so now if we look here, we have a 4 and we have an 8, and I'm sure we can agree that the greatest common denominator between 4 and 8 is actually just 8. So what we're going to do is we are going to multiply everything by 8. So we're going to multiply this by 8. We're going to multiply this by 8. And we are going to multiply this by 8. And you will see that if I multiply fractions by just a regular number, we just multiply across the top, because this is kind of like 8 over 1, 8 over 1, and 8 over 1. And so over here in the first fraction, we're going to get 24 over 4x minus, over here we're also going to get 24 but over 8x. And over here we're going to get negative 48. Now, can we simplify? Well, yeah, we can simplify because 24 divided by 4 is 6x. And here is just minus 3x. And that's equal to minus 48. Now, doesn't this seem a lot easier than what we had to begin with? So over here, you would have noticed, actually, that these 8's here, they could have actually canceled out because you're left with a negative 3x. So keep that in mind when you're doing it. You can actually just cross them off because 8 divided by 8 is just 1. So we were just left with what was on top in the numerator down here. So now if we continue, 6x minus 3x is 3x, and negative 48 stays here, and then you divide both sides by 3, divide by 3, and we get that x is equal to negative 16. And that is the answer on how to do it by finding a common denominator and multiplying everything by a common denominator. The other way that we could have done this is by cross-multiplying. So in this case, I rewrote what we had at the first slide. This is where we're at in the first slide. Now, when you cross-multiply, and this is very important, you have to have one fraction, okay, on either side of the equal sign. Now over here we have two fractions, but it's very simple. We can change these and get a common denominator. And to do that, we're going to multiply this by 2 over 2. And if we do that, we get 6x over 8 minus 3 over 8x is equal to negative 6. Now, do we have a common denominator? Absolutely. What's 6x minus 3x? Well, it's just 3 over 8. And then x is equal to negative 6. Now we can cross multiply. Now, but I say here, I say one fraction on either side of the equal sign. So here's a fraction, but is negative 6 in a fraction? Well, of course it is. It's kind of like under an imaginary 1 here. So if I do this, like it's kind of like an imaginary 1. So let's cross multiply. Now, if you remember how to cross multiply, it's literally multiplying across like this. So 3x times 1 is just 3x, and negative 6 times 8 is negative 48, and we divide both sides by 3. We divide both sides by 3, and voila, we get the same answer that we got on the first method, which is 16. So you'll notice that over here we ended with the exact same as over here. And that's how you do it. But to remember, to do cross multiplication, you have to have one fraction on either side of the equal sign. So we had to actually find our common denominators to meld these two together, and then we get x is equal to negative 16. So that's how you answer this type of question. Here's a special case. Say you have an x in the denominator. So over here there is an x in the denominator, as you can clearly see, and we have some these terms here do not have an x in them. So when that happens, we want to have x on one side and our numbers on the other. So all I'm going to do is I'm going to bring over this 3 over 2 to the other side by doing minus 3 over 2 minus 3 over 2. And then I'm left with 4 over x is equal to 5 over 3 minus 3 over 2. Now, the best and easiest way to do this is to cross multiply, because method 1 won't work since we cannot find a common denominator if we don't know what this x is. So what we're going to do is we're going to bring these two fractions together by finding their greatest common denominator, which in this case is 6. So I'm going to multiply my first fraction here by 2 over 2, and I'm going to multiply this fraction here by 3 over 3. And I'm going to be left with 4 over x on one side and 10 over 6 minus 9 over 6. Now I have a common denominator, so now I'm going to go 4 over x is equal to, well, 10 minus 9 is just 1 over 6. Now I can do method 2, which was cross multiplication, because I have a fraction on either side of the equal sign. And if I do that, keeping my x's on the right side, because I favor that, x is equal to 24. And that is the answer. So just to recap, if you have an x in the denominator, the only method you can do is method 2. Method number 2. Okay, that's the only method you can do when the x is in the denominator. And method 2 was cross multiply, just to remind you. So just to recap, let's cross multiply. Just to recap, if we go back to our first slide, I gave you an equation that looked like this, where we had a fraction with an x on both sides, and we brought them together by subtracting our 2 on both sides and bringing our 3 over 8x on the other side. I showed you two ways. One, multiply everything by the common denominator, and in our case the common denominator was 8, and we got this really nice and simple equation when we multiplied everything by our common denominator, which was 8, and we got x is equal to negative 16. Or I showed you a second case where you can cross multiply, but the issue with this is that you need to have one fraction on either side of the equal sign to do this. And to do that, we had to make sure that we find a common denominator with both of our fractions to add or subtract them in this case. And once we had one fraction on either side of the equal sign, remembering that everything, a whole number, an integer, is over 1, we just cross-multiplied across, and we got 3x is equal to negative 48 and x is equal to negative 16. And finally, I showed you a special case when x is in the denominator. The only method that is very simple for you is method number 2. Of course, you might favor changing things into decimals, but these lessons are to encourage actually keeping fractions because it might actually be an easier way to solve for your equation.